Hi everyone, welcome back to Made Everything Official. In this advanced facility, molten steel and stainless steel are transformed through hot extrusion technology, a process chosen when precision and complexity meet. At temperatures exceeding 200 degrees Celsius, solid billets are preheated and forced through hardened dies under immense hydraulic pressure. This method allows engineers to create intricate profiles and hollow sections that would be nearly impossible to form by rolling or casting. Hot extrusion provides exceptional material flow, uniform grain structure, and dimensional accuracy, ideal for aerospace, automotive, and heavy industry applications. Versatile, efficient, and built for demanding geometries. This is the art of shaping steel under heat and pressure. Hot rolling remains one of the most efficient and cost-effective methods for producing special profiles in steel and stainless steel. Red-hot billets are passed through a series of heavy rollers, gradually shaped with precision while maintaining structural integrity and consistency. The intense heat and pressure refine the grain structure, improve toughness, and deliver a smooth, uniform finish ready for further machining or fabrication. Founded in 1990 in Cork, Ireland, AMS has grown from a modest 86,000 square feet facility into a state-of-the-art 250,000 square foot complex, driven by constant investment in advanced extrusion technology and automation. With 2 high-performance extrusion presses delivering more than 16,000 tons of aluminum annually, AMS serves diverse industries, from aerospace and transportation to renewable energy and architecture. Every die is maintained in-house, ensuring precision, consistency, and long service life. AMS operates both vertical and horizontal powder coating lines, achieving flawless finishes on profiles up to 7.3 meters long, using chrome-free pretreatment for a cleaner, safer environment. Its Decroll wood grain coating process combines beauty with durability, creating long-lasting architectural finishes without the maintenance demands of natural wood. Beyond extrusion, AMS provides turnkey fabrication for windows, doors, and curtain wall systems, complemented by an in-house precision sheet metal division capable of cutting, welding, and thermal insulation with unmatched accuracy. Through innovation, craftsmanship, and environmental responsibility, AMS continues to redefine aluminum manufacturing, stronger, smarter, and more sustainable than ever. In today's factories, the biggest challenge is maintaining production when skilled workers are hard to find. That's where automation and cobots step in, designed to keep output high and consistent. Operators now oversee multiple cobots at once, focusing on quality monitoring and precision adjustments instead of repetitive labor. The result is greater accuracy, consistent performance, and zero human error. These collaborative robots handle everything from CNC milling and turning to part trimming and grinding, and even pick-and-place assembly. With an average return on investment in just 6 months, automation is more than efficiency. It's a smarter way to manufacture the future. From molten metal to precision coils, every step in aluminum production is a story of technology and control. It begins with casting and rolling, where liquid aluminum solidifies into sheets under immense pressure. Through cold rolling, these sheets are refined again and again, achieving the exact thickness and strength required for industrial use. Each stage reflects precision, efficiency, and sustainability, producing high-grade aluminum for automotive, construction, and electronic applications worldwide. Next comes cleaning and degreasing, removing even the finest traces of oil or residue to prepare for perfect surface quality. Then, during annealing, heat treatment restores flexibility and structural integrity, ensuring the coils are ready for shaping, coating, or forming. This is how advanced cold rolling turns raw metal into the foundation of modern innovation. In modern metallurgy, the 5A aluminum alloy family, 5A02, 5A03, 5A05, and 5A06, represents a perfect balance between strength, flexibility, and corrosion resistance. Built on a magnesium-based system, these alloys belong to the non-heat treatable series, where strength is enhanced through precision cold working rather than thermal hardening. Each plate and coil carries the signature of advanced engineering, lightweight yet incredibly strong, with a high strength-to-weight ratio surpassing that of conventional 1XXX and 3XXX series alloys. Their resistance to fatigue and excellent weldability make them the preferred choice for demanding structures, from marine vessels and pressure tanks to aerospace components and transport frames. To ensure durability, every batch undergoes a stabilizing process after cold deformation. This critical step controls residual stress and prevents corrosion, maintaining metal stability under conditions not exceeding 65 degrees Celsius. The manufacturing precision is equally impressive. Coils can reach widths up to 2,500 millimeters, while plate thicknesses range from 6 to 150 millimeters, accommodating everything from lightweight panels to heavy-duty industrial parts. Through strict inspection, controlled rolling, and finishing, each sheet achieves uniform texture and flawless surface quality. Whether used in aviation, marine engineering, or high-performance manufacturing, the 5A series defines reliability where strength meets precision, a true benchmark in the evolution of aluminum technology. At Montanstahl, innovation takes shape through Davex technology, a unique roll-forming process that transforms precision into strength. It begins with a locator groove, carefully machined along the flanges to ensure perfect alignment. Next, a special embossed pattern is applied to the web edges, creating a mechanical bond that locks components together with unmatched rigidity. Davex technology represents the future of steel and stainless steel profiles, combining mechanical precision with design freedom for modern engineering. Once aligned, the web is seamlessly set into the flange grooves, forming a single, solid profile, stronger, lighter, and more efficient than traditional welded structures. Every aluminum aerosol can begin its journey as a simple flat sheet of high-purity aluminum alloy. What follows is a process of transformation, precision, pressure, and perfection, where metal meets innovation. The sheet is first fed into high-speed cupping presses, where discs are punched out and deep drawn into cylindrical cups. This is the moment raw material becomes potential. Each blank is carefully lubricated, then transferred automatically to the next forming stage. Through multiple drawing and ironing steps, the metal is elongated and thinned, forming a perfectly smooth, seamless can body. This technique ensures lightweight strength, the ideal balance of flexibility and durability for products stored under pressure. After forming, the cans move through a precise trimming machine that removes the uneven rim, achieving consistent height across thousands of units per hour. No sharp edges, no variation, just flawless geometry. Next comes internal cleaning and coating. In this stage, every can is thoroughly washed to remove microscopic residues of oil or metal dust. The interior is then sprayed with a special protective lacquer, a barrier against corrosion and chemical reaction, ensuring absolute safety for cosmetics, paints, food aerosols, or pharmaceuticals. Once the inside is protected, the outside receives its identity. On the decoration line, high-speed offset printing machines apply brilliant, multicolor designs. The cans are baked and varnished, locking in both color and gloss. Brand recognition, durability, and precision merge into one continuous process. At the necking station, a series of progressive forming dies gradually shape the can's upper profile. This carefully engineered contour ensures the valve fits perfectly, maintaining pressure integrity while optimizing material usage. The precision is measured in microns, because even the smallest deviation can affect sealing performance. Every finished can then goes through strict quality control. Automated systems perform visual inspections, leak detection, and dimensional checks, while high-pressure tests confirm each unit can safely contain its contents under stress. Defective products are rejected automatically to maintain zero-compromise standards. Finally, the aerosol cans are palletized, shrink-wrapped, and prepared for transport, ready to be filled with a wide range of products: deodorants, paints, industrial lubricants, or even medical sprays. Each can is a testament to modern manufacturing precision. Lightweight yet strong, functional yet beautiful, sustainable and infinitely recyclable. From flat metal to functional art, the aluminum aerosol can is a small wonder of engineering, protecting products, preserving pressure, and enabling convenience across the world. This is not just packaging, it is a symbol of industrial evolution, where science and craftsmanship work hand in hand to serve billions of consumers every day. Every precision profile you see begins as a solid aluminum billet, stacked and ready for transformation. The billet is first preheated to around 400 to 480 degrees Celsius, softening the metal to a malleable state while preserving its strength. Next, the billet is loaded into the extrusion press. A powerful hydraulic ram drives the metal through a steel die with the exact cross-sectional shape required. The aluminum flows, takes form, and emerges as an extruded profile. As the material exits, it's immediately stretched, cooled, and straightened, ensuring perfect alignment and optimal mechanical properties. The profile may then undergo aging or heat treatment to lock in its performance characteristics. The final result: lightweight yet rigid, corrosion-resistant yet precisely shaped. Aluminum extrusions ready for architectural frames, industrial structures, electronics housings, or transportation components. With this process, form and function meet in metal.